There is a planet in the universe that fooled humanity. When astronomers first detected its light, it appeared to be a calm, brilliant blue world, almost like a larger, more mysterious version of Earth. From a distance, its color suggested oceans, clouds, perhaps even the possibility of life. But as more powerful telescopes began to uncover its secrets, that beautiful illusion slowly fell apart. There were no oceans, no continents, no solid ground, no chance that life, as we know it, could ever exist there. Instead, scientists found a giant world where temperatures soar beyond 1,000 degrees Celsius, winds race through the atmosphere at nearly 9,000 kilometers per hour, and microscopic particles of molten glass are hurled sideways with unimaginable force. This planet carries an unremarkable catalog name, HD 189733b. But behind that ordinary designation lies one of the most extraordinary worlds humanity has ever discovered, and one of the greatest achievements in modern astronomy. The obvious question is, how do we know any of this? How can we measure the weather on a planet that no human has ever visited? How can we determine the color of its atmosphere, estimate the speed of its winds, or identify the molecules drifting through its skies when it lies roughly 64 light-years away from Earth? The answer is far more remarkable than the planet itself, because it tells the story of how humanity learned to study worlds that are so distant. Even light, the fastest thing in the universe, needs more than 6 decades to reach us. For most of human history, we believed our solar system was the blueprint for every planetary system in the cosmos. The inner region was occupied by small rocky planets like Mercury, Venus, Earth, and Mars, while massive gas giants orbited much farther away, where temperatures were low enough for enormous amounts of hydrogen and helium to accumulate. It seemed logical. If planets existed around other stars, surely they would be arranged in much the same way. After all, the solar system was the only example we had. Nature, however, had no intention of following our expectations. Everything changed in 1995, when astronomers announced the discovery of the first planet orbiting a sun-like star beyond our solar system. The discovery confirmed a centuries-old hypothesis, but it also shattered one of astronomy's strongest assumptions. The planet was a giant gas world comparable to Jupiter, yet it orbited astonishingly close to its star, completing an entire year in only 4 Earth days. According to the theories of the time, such a planet simply should not have existed there. If one giant planet could completely ignore the rules, perhaps the universe had never been following those rules in the first place. Over the following decades, discoveries accelerated at an extraordinary pace. New observatories, more sophisticated instruments, and increasingly precise detection techniques revealed hundreds, then thousands, of planets scattered throughout the Milky Way. Some reflected almost no light, making them darker than charcoal. Others were so intensely heated that metals likely evaporated into their atmospheres. Scientists found enormous planets with densities lower than water, worlds orbiting 2 stars simultaneously, and planets where a single year lasted only a matter of hours. Every new discovery expanded the boundaries of what we believed nature was capable of creating. Gradually, astronomers realized something profound. Our solar system was not the standard model of planetary systems. It was simply one possibility among countless others. It was during this exciting period of discovery that astronomers turned their attention toward a relatively nearby star located about 64 light-years from Earth in the constellation Vulpecula. The star itself carried an uninspiring catalog designation, HD 189733. Like millions of other stars listed in astronomical databases, its name revealed almost nothing about its importance. When researchers confirmed the existence of a planet orbiting it in 2005, they simply added the letter B, indicating it was the first planet discovered around that star. At the time, few people suspected that this seemingly ordinary object would become one of the most intensively studied exoplanets in history. What made HD 189733b so valuable to scientists wasn't simply its existence, it was its perfect alignment with Earth. Every little more than 2 days, the planet passes directly in front of its star, allowing a tiny fraction of starlight to filter through its atmosphere before reaching our telescopes. That light carries invisible fingerprints. Every gas absorbs specific wavelengths, leaving behind subtle clues that astronomers can decode. Without sending a single spacecraft across the 64 light-years that separate us, humanity learned to read the chemistry of an alien world simply by studying its light. The discoveries came one after another. Scientists identified water vapor, carbon monoxide, methane, and clouds filled with tiny silicate particles. Those same particles turned out to be responsible for the planet's beautiful blue appearance. At first glance, the color resembles Earth's oceans, but the resemblance is nothing more than a cosmic illusion. There is no water waiting beneath those clouds, only an immense atmosphere of hydrogen and helium wrapped around a scorching gas giant. The planet belongs to a class known as hot Jupiters, enormous gas giants that orbit incredibly close to their stars. HD 189733b circles its orange dwarf star at a distance of only about 4.7 million kilometers, completing an entire orbit in just over 2 Earth days. At that range, the star dominates the sky forever. One side of the planet constantly faces the star, while the opposite side remains trapped in endless darkness. There are no sunrises or sunsets, only permanent day and permanent night. That eternal imbalance creates one of the most violent climates ever discovered. Temperatures on the day side exceed 1,000 degrees Celsius, while the night side remains hundreds of degrees cooler. Nature constantly tries to restore equilibrium, driving colossal atmospheric currents around the planet. Those winds can reach nearly 8,700 kilometers per hour, roughly 7 times the speed of sound in Earth's atmosphere. Nothing in our solar system experiences weather on this scale. Those supersonic winds also gave birth to one of the most famous headlines in modern astronomy: the planet where it rains glass. While that description is somewhat simplified, the underlying science is just as extraordinary. Under the planet's extreme temperatures and pressures, silicate compounds can condense into microscopic droplets or crystals. Instead of falling gently like rain on Earth, these particles are immediately swept sideways by the planet's enormous winds, creating horizontal storms of superheated glass, moving at incredible speeds. It is a world where even the atmosphere itself has become a weapon. Imagine approaching HD 189733b aboard a spacecraft. At first, the blue glow would look peaceful, almost inviting. But the closer you came, the more hostile the environment would become. The temperature would climb relentlessly. The atmosphere would grow denser with every kilometer. Violent turbulence would shake the spacecraft as global winds battered its hull from every direction. Deeper still, crushing pressure would overwhelm even the strongest materials ever engineered. Long before reaching anything resembling a surface, the spacecraft would simply be destroyed. In reality, there is nowhere to land. Like Jupiter, HD 189733b is almost entirely atmosphere, growing denser and hotter the farther down you travel. Despite its terrifying nature, this distant world changed astronomy forever. Before planets like HD 189733b were discovered, studying the atmospheres of exoplanets seemed almost impossible. Today, the same techniques developed through observing this planet are being used to investigate hundreds of other worlds across our galaxy. Every improvement brings scientists one step closer to detecting the chemical signatures of truly Earth-like planets. and perhaps one day, evidence of life beyond our solar system. Ironically, one of the most uninhabitable planets ever found has become one of humanity's greatest allies in the search for habitable ones. HD 189733b taught us that appearances can be deceiving, that blue does not always mean oceans, and that distant starlight contains far more information than anyone once imagined. It reminded us that the universe is under no obligation to resemble our own neighborhood, and that every new world has the potential to rewrite what we think we know about planets. Somewhere, 64 light-years away, this blue giant continues racing around its star every 53 hours, wrapped in storms of molten glass beneath a sky no human will likely ever see with their own eyes. Yet despite the impossible distance, we have uncovered its secrets from across the galaxy using nothing more than light, mathematics, and curiosity. And perhaps that is the most extraordinary discovery of all, not the planet itself, but humanity's remarkable ability to understand places it may never physically reach,